Hello everyone, I hope everyone is doing well. We're going to look at a problem that has to do with function composition, and we're being asked to determine the domain, right? So let's look at this problem. We're given f of x is equal to the square root of x plus 1 and g of x is equal to 2 over x. And we're determining the domain of f composite g of x. What we're going to do first is try to look at the behavior of f and of g, and we are going to try to find their domains separately. So for the domain of f of x, since we know that f of x is defined as square root of x plus 1, and whatever is inside the square root cannot be negative because it wouldn't be defined in our set of real numbers. So we want to make sure that x plus 1 is greater than or equal to 0. If we subtract 1 from both sides, we then have that x has to be greater than or equal to negative 1. When drawing this in the number line, we know that if we were to plot the point negative 1 in our number line, since I want the points that are greater than or equal to 0, all of those numbers are going to be to the right side of negative 1. So if I were to shade the representation of this inequality in the number line, we'd then be having this side. So what does this mean? Well, our domain in interval notation for the function f is going to be the interval from negative 1 all the way to infinity. So this is our domain of f. Now let's look at the domain of g. For g, things are actually also a little bit simpler because we know that g is defined as 2 over x. Whenever we have a quotient, we know that the denominator cannot be equal to 0. So we're going to make sure that x is not equal to 0. And if we were to draw this out in interval notation, let's look at the number line. We'd then have that when plotting 0, I'm going to put an open circle there, meaning I'm not going to consider 0, but I'm going to consider everything else. So I'm able to shade the right side, the left side, and the right side, which means that our interval for the domain of g would be from negative infinity all the way to 0, but once again, I'm not including 0. So I'm going to put a parentheses there, and I'll take the union from the right side of 0 all the way to infinity. And this would be our domain in interval notation, which just means that I'm only excluding 0. Now let's try to look at how is the function f of g of x defined. So this might be a little tricky for those that are new to this concept, but think about the following. Suppose that I were to ask you to, let's say, to evaluate f of 2. All that you basically do is wherever you see an x in your function f of x, you're now going to substitute that by a 2. So we're going to have that this would be the square root of 2 plus 1, which is the square root of 3. And we know how to evaluate with any other number, as long as that number is part of our domain. Let's say that I were to then ask you to evaluate f of z, for instance. Well, it might look a little tricky, but all I'm doing is following the same rule. In other words, where I have x, I'm now going to put a z, which is our input. So this is going to be the square root of z plus 1. And that would be f of z. So when I'm looking at the function composition, I like to look at it this way. because if I'm considering the composition of f of g of x, I can write it this way, f of g of x. And at the same time, just to make this expression a little shorter, I'll write it as f of g. But I mean, here I'm not being 100% formal, since this would be the accurate way to write it, but this is just so that you could understand a little better as to how we generally do this. Let's remember what f does to its input. So if I have f of g, just like I did with f of z, what I'm considering would be the square root of g plus 1. And we know what g is equal to. We know what that function is. That function is 2 over x. So now, wherever I see a g, I'm going to plug in 2 over x. So this is going to be the square root of 2 over x plus 1. And this would be our function composition. This is f of g of x. So now what we're going to do is we're going to determine the domain of f of g. So this part might be a little tricky initially when you're just getting started with these concepts, but hopefully things will add up here. Let's first look at what's happening here. When we're taking f of g of x, we're first plugging in a value for x into g. That's what we're doing. So let's remember, we can plug in any number inside of g except 0, right? So right away, we know that the domain of f of g will be excluding 0. So let's put x cannot equal 0 here. Right? But at the same time, we know that whatever we input into our function g has to belong to this interval. In other words, our input for our function f has to be something that goes from -1 to positive infinity. So what we're going to do is we're going to make sure that g of x is greater than or equal to -1, because we cannot allow anything else inside of f, right? And g is inside of f right now. So let's put that here. G of x has to be greater than or equal to -1. And what this means is that g of x, which we know is 2 over x, has to be greater than or equal to -1. So we're going to try to evaluate and solve this inequality. What we're going to do now would be the following. I'm going to set one side of the inequality equal to 0, so I'm going to add 1 to both sides. And this would then mean that 2 over x plus 1 is greater than or equal to 0. Now let's try to solve this. I'm going to make sure that this is written as one rational expression. So we know that our least common denominator is x, and we can then write this as 2 over x plus 1 times x over x, which is going to be equal to 2 plus x over x. So this has to be greater than or equal to 0. What I'm going to do now is I'm going to see when is the numerator equal to 0 and when is the denominator equal to 0. And I'll put those in the number line. So let's first draw our number line. And let's see. Let's analyze what's happening here. We know that our numerator 2 plus x will equal 0 when x is equal to negative 2, right? If you solve this equation, you'd subtract 2 to both sides, and when x is equal to negative 2, you get 0. So I'll plot negative 2 in our number line, and I'm going to put a closed circle there because if our numerator is equal to 0, then the entire expression, the entire rational expression would equal 0, and that number is allowed in our inequality since we're looking for those that give us something greater than or equal to 0. Now if we look at our denominator, we know that our denominator is equal to 0 if x is 0. So let's plot 0 in a number line. And I'm going to put an open circle for 0 because we know that we're not allowed to divide by 0. What we're going to do now is we're going to start seeing what's happening with the sign when we input values that are to the left of negative 2, in between negative 2 and 0, or to the right of 0. So let's start doing that. Let's take a number to the left of negative 2. For instance, let's consider x equal negative 3. So for x equal negative 3, when we input this into the rational expression, we have 2 minus 3 over negative 3. This is going to be equal to negative 1 over negative 3 and that is going to be positive 1/3. So we're going to put a positive to the left side of negative 2. This region will always generate positive numbers. Now we're going to input something in between negative 2 and 0. Let's say that I'll input negative 1. So for x equal negative 1, when we input that into this rational expression, this is going to give us 2 minus 1 over negative 1, which is equal to 1 over negative 1, which is negative 1. That gave us a negative number, so I'm going to put a negative on that region. Lastly, I'm going to evaluate at a number to the right side of 0, for instance at 1. So for x equal 1, I'm going to have 2 plus 1 over 1, which is 3. That gave us a positive number. So now let's look at what's happening here. When I input anything to the left of negative 2, I'll get a positive result. When I input anything in between negative 2 and 0, I'll get a negative result. And when I input anything greater than 0, I get a positive result. I want those that give me something positive because I want to make sure that all my results are greater than or equal to 0. That's what my inequality is asking for. So when I write our domain for the function composition in interval notation, we'd have that the domain of f of g is going to be equal to our interval that goes from negative infinity all the way to negative 2 union the interval that goes from 0 all the way to positive infinity. And this would be it. I hope everything made sense.